Hello guys and welcome back. So I have the sim here going and this is how it looks like. I imported it into the SOPs and I'm previewing it using these settings. And you can see now with just this idea we're getting this very interesting flame. It's also creating all these interesting rotation and a swirling motion automatically for us. Now look at how much details this has in here. You can see there is already a lot more details than what you can get with even a high-res sim from Pyro, and this is because we're capturing all the details from within the sim. We're not running it through any post-processing or any micro solvers to give us this result. We're getting directly the data that we need. The other cool thing, this behavior, if you've ever used DOPS, the Pyro solver, it's really hard to create because you can see here the fire is within and there is a lot of energy going inside, but it's not really affecting the outer layer. And this exact behavior is really hard to get. And the other part where I talked about the loop between the velocity and the temperature, you can see the effect here in this part. See how it's causing this section to go up really fast, and then the cooling takes over. It's also happening here. You can see how the sim was calm and then it received this fast moving part, which then got converted into the temperature that caused this section to rise. It's basically like a burning effect, that you can have a fast moving part of the sim that ignites certain other parts within the sim itself, and this is very natural, and it's really tricky to get something like this. Cool, so let's continue. We have this going, and I wanted to make sure that everybody understands what we're doing. So I'm going to show it in the in DOPS. In SOPs here, so I'm going to import the velocity. Let's import vel. I hope it's not gonna recache again. Cool. I'm gonna convert this into a VDB, and let's vector merge that. Okay. And I'm going to create actually I'm not going to create anything. I'm going to blast the density and rename it. I'm also going to remove the temperature so you guys are not confused by what we have already. So I'm going to remove it completely, and we should have temperature, density and velocity. Cool. And then I'm going to rename this to something else. I'm going to call it temp. Okay. And I'm going to merge all these guys together. And I'm going to use a volume VOP. And with this volume VOP, I'm going to bind the velocity. It's a vector. So vel. And let's compute the length of this guy. Fit range, and let's export this. This is exactly what we've done in DOPS. And I'm gonna export this as temp. I'm gonna export it into the temperature, the temp field that I just made. Actually, you know what? Let me rename this test temp, test field. So it doesn't have anything related to temperature. Okay, we have the min and max, and let's put down a visualization node. And under emission here, I want to use that, where is it? Come on. Oh, sorry, the cooking is turned off, yeah. Okay, let's add the test field, and let's add it here as well. And let's turn on both of these guys. Actually, let's leave them turned off for now. And I'm going to set these colors to red, green, and blue. Okay, almost there. Cool, let's set this to 1 and let's see what we have. Cool, so you can see we have a mask, and I'm not seeing any of the red information. That means the range that we have, the fit range is not capturing the full extent of the velocity. So let's try 0 to 10. Cool, so now we have red and we have green and blue. We have everything pretty much. Let's try 5. Let's set it to 10. And let's turn on the lighting back so we can see it better. Cool, so you can see we have the blue, the green, and just a tiny bit of red on the edges. Let's go to a different frame. Cool, let's set this to 2. And I'm going to set this red here to black. And I'm going to remove the green as well. So I just want one color, and I want to isolate that. Cool. So now you can see the fast moving parts are only within the volume, and this is really nice to use as a temperature. And our sim has already been modified to use to have this information injected, but basically that's what we're doing. We're isolating that part and using it as the temperature field, and you can see it here. Cool, so let's continue. We're going to inject something else now into this. So I'm going to dive inside the gas field VOP, and I'm going to use the dot product between the velocity and the temperature. I'm going to copy this fit range, and let's set it to -1 and 1. And we remember that -1 will give us things that are behind the volume, that are opposite of each other. 0 will be at the center basically, and 1 is where everything is moving forward. So if I put down a ramp, if I remember correctly, if we set this ramp like this, we are going to basically be using the front part. And I'm going to try that. I'm going to use this information now as the temperature. I'm not going to use the velocity, I'm going to use the magnitude. So what this should give me is the shell of the sim. And let's go back and let's see how that looks. I'm going to lower the resolution back to 4. Let's turn on some lighting and let's hit play. Okay, nothing is visible at the moment. So let's try this. And okay, cool. I'm just verifying. Okay, maybe the value is really weak. So let's multiply it and see how that looks. Multiply by a constant. And let's multiply it by 100. Still nothing. Okay. Add. Could it be? Let me double check. Yeah, we have the temperature. Okay. I'm not sure why this is not working. Let's try that. So I found what the issue is. The signature of this is a color, and it was changing the signature of this guy. So what I'm going to do is I'm going to put down a vector to float here and just export to float to make sure that I don't change the signature of this. And now if I hit play, you can see we're getting the data that we need. Cool. So let's try without multiplying it with the temperature, and let's try without multiplying it with the density, because that changes the value, and I want to see the raw data. And look at this, we have fire being emitted behind the sim, which means we're not capturing that front part, we're capturing the stuff behind. And this already looks very, very interesting to just be able to do this. But we can always multiply it with the density so it stays within the range, but there is no restriction. We can temperature, for me at least, I always have the temperature exist where there is density, but you don't have to. You can still have temperature everywhere within the sim like this. It's going beyond the information where we have density. And this is the other thing why I always wanted to multiply, because it's very important to be within the sim. So let's set this back to -1 and let's try and get the information correct. This is already looking very, very interesting. But again, we're getting everything at all parts of the sim. So let's multiply it back with the density. Cool. So let's go up and let's play with this gradient here, with this ramp. And let's be more aggressive. I don't want, you can see here it's black. There is no temperature, but it's only at the front, which is very cool. So let's play with this. I want it to be even thinner. Let's go even more. Yeah, so now it's even at the thinnest part of the sim, which is the shell basically. And this is one of my key secrets to create the rolling effect. What happens is when you have a sphere, and let's say we isolate the shell of this part of the sphere here, we only make the shell, which is a super thin layer out of this field, we make it really, really hot. The core, it's still really cold. What's going to happen is the sim is going to start to roll, and you're going to get that cold parts is going to get mixed and cause this temperature to behave very differently. As it's going to behave very differently compared to if everything was uniformly, if everything has the same temperature value. So isolating the shell will have an extra effect of adding a lot of interesting rolling effect. Probably it's too sharp right now, but mixing this with the temperature, with the velocity, can create some really, really interesting effect. And these basically are the two key secrets on how I create the temperature field manually. So this is the second one, and I generally make this really hot, and then I add it with this guy. So let's add them here, Let's multiply this. You know what, let me do this. Let me use a vector, just a vector from this guy, and then I'm adding it back to this, to the velocity here, which I'm actually going to change a bit. Instead of maybe 4, so it doesn't, between 4 and 20 it will not pick up anything that is moving really slow. So the ranges, we've moved it a little bit further, and I'm adding both of them back in, and let's see how that looks. Cool. So now we're gonna get anything that is fast moving and anything that is moving within the sim that has velocity that is aligned with the gradient. We're gonna get temperature, yes. And what this means is, let's say we have, for example, this shape, okay? We have the gradient like that. The dot product between the velocity and the gradient is going to isolate that shell. And as the gradient starts to bend away, it's not going to add any temperature. So the hottest part, the roundest gradient that is aligned with the velocity will always be hot. And this is very unique characteristic of the sim. It's going to create very, very interesting details in the fire. So let's go back here and let's visualize this. Cool. Let's hit play, and now you can see it's gonna work much better than having just the temperature, the velocity in. So one last thing, this is a prototype that you guys can investigate. We've done this, so what I'm going to do is I'm going to copy this ramp. I'm going to call it ramp negative, and let's go up. And with the ramp negative, I'm going to set the colors like this. And I'm going to multiply it by a constant, and then I'm going to add that here. So we're going to multiply, we're going to isolate a different part. So basically the idea is we have everything moving, is getting super hot, and I want to isolate anything that is not moving and not facing the gradient to have a negative temperature, and I will show why in a second. So here under the, let me rename this so we know, negative temperature. And again, this is just an idea. I have not used this in production, but I think it can result on creating some really, really interesting effects. So the idea here that I'm trying to add, if we have super hot temperature at the edge and then negative temperature on anything that is backward, we can get a lot more interesting mixing happening within the sim. Now, as how this will translate within the sim, I'm not entirely sure, but I think it can create even more interesting bubbling effects. Cool. I think this covers pretty much everything about the temperature for now. The next thing that we're going to talk about is the expansion. Right now we have only temperature and it's interacting with the sim, it's adding a lot more details, but we're not getting any expansion. And in real life, when you have an explosion, you have a huge expansion at the beginning where there's a lot of fire, there's a lot of ignition, and then as it cools down, it expands less and less. In explosions, also the first 10 frames of the expansions are really drastic, and then as it evolves, the hottest part will still expand and rise up. So we're going to learn how to add that, but this is the starting point. Now what I'm going to do is I'm going to increase the resolution of the sim. I'm going to turn off the negative temperature, but definitely explore that, see if you can get anything interesting out of it. And then the advection here, see this time scale. I'm seeing the leading, the edge is going beyond the density. So I'm going to scale the time, I'm going to reduce the time scale so there's a little bit of delay between the custom temperature and the sim. And I just realized why this is happening. It's because the sim is running using BFECC and those are not. That's why this is happening. But I will leave this. I'll leave it at 0.9. Okay, let me reduce the resolution. Reduce this to increase the resolution. And I'm gonna cache this and we'll continue in the next video. Thank you guys for watching and see you in a bit.